Hey everybody, today's video is going to be about something called the Shapley value. Now, as I often do, I'm going to start this video with a bit of a puzzle. So let's say it's late at night and you and your friend here have just left the bar, or the club or whatever. This is the club here. And you've both been drinking, so you can't really drive home, so you're going to get an Uber. Now, if you got the Uber by yourself to your house, it would cost you 20 bucks. If your friend got the Uber to their house by themselves, it would cost them, let's say, 30 bucks. However, if you and your friend both got the Uber together, which is something the Uber service offers, it'll drop you off first and then drop off your friend. It'll only cost the group of you $40. Now, the question here that this video is going to sort of be tackling is, how should you divide this $40 cost between yourselves? Now, obviously, this idea of fairness is more of a moral, philosophical one that you can't really reduce down to math. In actuality, in this system, I'd be quite happy to just split it with my friend and say, I'll pay 20, you pay 20. But what I'm interested in here more is if we can codify this mathematical notion of fairness and what it means to be fair. We've talked a lot on this channel about game theory, mainly competitive game theory. So game theory that involves competing parties and trying to get an edge on your opponent. This is a different field of game theory called cooperative game theory, which is basically the study of what's fair. And the Shapley value is an equation that you use to solve things like this. This is the equation here. We're going to talk a little bit about how it's derived, but not really the specifics of what these symbols and stuff actually mean. I just thought I'll put it up here if anybody's interested. So a naive approach would be, me and my friend are just going to split it 20-20. Now, in theory, I'm pretty happy with this because I was already paying 20, so I haven't paid any more. And my friend, she's stoked because she is now paying $10 less than what she was going to pay. She was going to pay 30, now it is just 20. One thing we can say about the system is that there's been $10 of surplus created. $10 of surplus. And surplus just means value added. Or in this case, cost taken away. Combined, you and your friend were going to pay $50, and now you're only paying $40. So as a group, you've created $10 of surplus. Now, if you and your friend do this 20-20 split idea, basically you're going to be saving nothing, against what was naturally going to happen, and your friend is going to be saving $10. So they're sort of getting all the surplus to themselves. And I think that's partly why this feels a bit unfair. If you want to get more of a feeling for why this is unfair, multiply all the numbers by 100, and then it becomes a bit more clear that you're getting a bit ripped off here. So a fair response would be to split the surplus value together. And that would be you paying 25. No, sorry. You paying 15 and your friend paying 25. So the sum, I'm adding these numbers together by the way. The sum should be 40, which is correct. And you've taken a $5 saving and your friend's taken a $5 saving. This seems quite straightforward. And it gets a lot more complicated when I add a third person into the system, which we'll talk about in a minute. So we've just done a very simple application of the Shapley value. And now I'm going to give another example, this time in a business context. So let's say you have a solo venture where you're producing something. Let's say you make cookies and you've got a friend who also makes cookies. And you guys realize that if you combine your resources as a team, you can make more money per hour than you both do individually summed together. So I'll put some numbers to this real quick. So person A, let's say on their own they're making $10 an hour. I'll just write 10 per hour. And we'll say $10 per hour. And person B on their own is making $20 per hour. So person B is a lot better than person A at whatever this thing is. But if A and B combine their resources together, as a group, they will make $40 per hour, which is quite nice. So again, a naive response would be, well, A and B are in a business together, they're 50-50 partners, so they should just split their profits 50-50, meaning A and B both take $20 an hour away from this business. But now it's like, why would B agree to this? I mean, person B was already making $20 an hour. All the surplus value went to person A. Person A got a big financial boost, and person B didn't really get any advantage at all. So again, we're going to calculate a surplus value created in the system, which is $10 of surplus. And we're going to divide it between both people. So person A in this scenario here should be walking away with 15. Person B should be making 25. And you'll notice these are actually the exact same numbers that I've used for the Uber question, but this time money is good, not bad. These are profits instead of costs. Now, to give a more formal reason of why we're calculating things this way, I'll show you where we actually get these numbers from. We're going to consider the business starting empty and then slowly adding people into the business. Now, because there's only 2 people, there are only 2 orders that we can add people into the business. We can either have person A first and then add B, or we can have person B first and add A. And here I'm going to talk about the value they provide to each other. So in this scenario, we have person A in the business. They're making $10 an hour. And then when person B arrives, the business goes from $10 an hour to $40 an hour. So the person B is adding $30 of value. Now if we do it the other direction, we start with person B, who's making $20 an hour. And then person A joins, the business goes from 20 to 40. So person A is adding 20 of value. Now what the Shapley value says we should do is add these sums together. And these numbers here are going to give us the sort of ratio by which we should divide the profits. So 30 to 50 is a 3 to 5 ratio. So if we're doing a 3 to 5 ratio over $40, hopefully you can see that that gives us 15 to 25 because these numbers sum to 40. This is an 8-part ratio, and each part is equivalent to $5 because 40 divided by 8 is 5. So 15 for person A, 25 for person B, and this is the same thing as splitting the surplus. This is just what the math behind it is. Now the reason I show the math behind it is because we're now going to add a third person into the system to show how much more complicated things are going to get. So let's do that. I'm going to write them up here now. So we'll stick with some of the similar numbers. I'm just going to write the number here, not the per hour. Person A is making 10 an hour. Person B by themselves is making 20 an hour. Person C, who's a new person, is making 20 an hour as well. These are all the people, all the profits people are making by themselves. Now, if person A and B can combine resources, they will be making 40 an hour, as we've already discussed. If person A and person C combine their resources, they will be making $50 an hour. And if person B and person C combine their resources, they will only make $40 an hour. And finally, if all 3 people combine their resources, they can make $60 an hour. So the question is, when person A, B, and C all combine their resources, how should they be splitting the $60 an hour profit? Now, one interesting thing to notice here is that the sum of B and C is 40, and when B and C work together, they actually produce 40, which means that if person A wasn't in the system, person B and person C would have no incentive to work together because they're joining together and they're still making the sum of their parts. That means that they have what we call zero synergy. And if you and a business partner have zero synergy, it means you have no game theoretic incentive to align with them because you're both making the same on your own as if you were together. So just, stay separate. Now this idea of synergy is very common in the business world. This happens all the time where you know, basically every trade that happens will involve some kind of surplus value, and in the spirit of fairness, we'd like to delineate that surplus as easily as we can, or as fairly as we can. So, you know, if two people are small business owners and they want to share office space, for example, that's an example of them creating surplus with each other. They might want to do a calculation like this. Anyway, we need a table again. I've actually pre-made a table because I don't want to draw it all out. You'll notice this time we have 6 columns, and that's because now there are 6 orders in which we can add the people into our system, which is 3 factorial. There's 6 combinations, and you see them all listed here. So let's go through them. In the first scenario, person A is by themselves. It's a bit cut off, I can see from in the video. Let me just move it over here. This should be easy to see. Yeah, cool. All right. Now, person A joins first in the scenario. So if it's just person A in the business, they're making 10. When person B joins, we're going to go from 10 to 40. So person B is adding 30 of value. And then when person C joins, we're going from 40 to 60. So they're adding 20 of value. And we're going to keep filling out the table in this way. So just get rid of these, put that back. All right, if it's ACB, A is making 10. When C joins A, they go right up to 50. So C's adding a lot of value. And then B just adds a little bit at the end. Now BAC, B on their own, makes 20. Now if A joins first, A is adding 20 of value. And then C is adding 20 of value. If it's BCA, B's here, and then C's adding 20 of value. Then A adds 20 value. If I go CAB, now C starts by making 20. And when A joins, the value goes up to 30. And then B just brings them to 60. And then in this final scenario, C's here. When B joins C, B is just adding 20 of value, and then A gets to add the other 20 of value. Cool, so we're done. We've considered all 6 possibilities, and now what we have to do is sum up these values again. And I had the solutions written somewhere, just because I can't be bothered doing it all myself. These are going to give you ratios, and when those ratios get divided over 60 in the same way as before, what we end up with is that person A should be receiving roughly $18.33. Person B should be receiving roughly $18.33, and person C should be receiving roughly $23.33. And that is our finding from the Shapley value. Hopefully you can see in this equation sort of where it kind of relates. I think this section here is to do with the combinations. So you see these factorials here, obviously referring to the number of rows. And then we're summing up values, which makes sense. This creates the average. And this means the difference in value that you provide with your teammates versus you on your own, which is kind of like what we're calculating in every cell here. So these are our solutions, and a couple of things jump out at me. Firstly, it's that person A and person B are making the same amount of money, which is weird because when they were on their own in the solo venture, person A was just so much more useful than person B. So it feels like person B is kind of getting unfairly punished, right? Why is person B only making the same as someone who's a lot worse than them as an individual? And the reason is purely because person A has far more synergy with C than B does. So when B and C join up together, as we said earlier, they don't create any surplus value. You know, if B and C are on their own versus together, it does the same thing. Whereas A and C, when they're on their own, they're making 30, and when they join up, they make 50. This is what A is getting compensated for. This is why A is making the same amount as B, because even though they're way worse than B on their own, they're obviously more of a people person. They're better at creating synergy with other parties. Cool. All right. So that was a three-way example of the Shapley value. Now, a couple of other things I want to talk about with the Shapley value. Why is this the method we choose to decide what's fair? Because again, this idea of fair is still quite arbitrary. There are 4 principles that I want to talk about that we vaguely care about in fairness, and the Shapley value likes to preserve all those principles. So the first one is efficiency and efficacy. Basically what this says is that when I sum up my values, they are actually going to equal my total. So if these 3 numbers here didn't sum to 60, we'd have a huge problem. So that's efficiency. That one's pretty straightforward, obviously, otherwise the algorithm wouldn't work. The next one is symmetry, which says that if 2 people are completely identical and it's symmetrical, they should both receive the exact same share. So again, this isn't true for B and C, because B and C aren't symmetrical, because C has more synergy with A. But if I had a 2-person situation where they both make 10, and then when combined they make 30, the principle of symmetry would say that person A and person B need to be profiting the same amount, and symmetry is preserved under the Shapley value. If I go back to the Uber example, this could be like if the town is here and me and my friend's houses are here and here. You know, the shared Uber can go this way or it can go this way, but we're both kind of in a symmetrical environment. We should both be paying the same amount. The 4th principle is the principle of the dummy player. Now, a dummy player in cooperative game theory just means someone who enters the system and doesn't contribute anything. And the rule of the dummy player is that the dummy player needs to receive 0. So basically what this means is that if we had a person in the system who couldn't make anything on their own and didn't add any contributions to other people, their final sum in the Shapley value has to be 0. Otherwise, they're getting money for doing nothing, which is not fair. So the dummy player principle is also fully reinforced by the Shapley value. This would be like if I had person A who can produce 10 and person B produces 0, and then A plus B produces 10. Obviously in this system, player B is a dummy player because they can't produce anything on their own and they have no help for A. They haven't increased the value by joining A. So by the dummy player principle, person B needs to be getting 0. Now keep in mind that even if B could make 0 on their own, by joining A, if they could make 11, then yeah, B would have some entitlement. I think precisely to 1/2 would be B's entitlement, because they have contributed here, because they helped A make more. This is actually how most businesses work, where everyone's solo contributions actually will be 0, because no one person can run a business of a certain scale. You could think of this as like your HR department and your engineers and your stock traders, whatever, different roles in the company. On their own, they're useless, but together they have synergy. And the final principle is additivity, which just means that if I take 2 games or 2 situations and I analyze the Shapley values, if I combine the games together, combining all these values, the Shapley values also need to combine. So this would be like, for example, if I had a completely separate situation where A, B, and C have a second business, if I add all the values together and create a mimic table for like two businesses combined, these values here need to be the exact sums of the 2 businesses as individuals. You know, imagine you and your friends have to get 2 Uber rides together. The fact that you added a second Uber ride shouldn't affect the total sum. That's additivity. And yeah, these 4 principles feel like they're really important for fairness, and they are all being observed by the Shapley value, which is good. And yeah, I think that's about all I have to say about the Shapley value. It's fun to consider when these situations come up in real life. I know splitting the Uber is a really big example. So next time you're with your friends and something like this happens, maybe just consider this for fun. It's a fun little calculation to make the study of what's fair. Cooperative game theory is something that I don't know much about, and this is a very entry level topic. But there are a lot more people more educated than me who can talk about this formula and how elegant it is. But I think that'll be all for me. So yeah, that's the end of the video, and cheers for watching, guys.